Welcome everyone. In this lesson, we're going to learn how to differentiate a function by using logarithmic differentiation. So suppose you're giving this function and your goal is to find dy dx, meaning the first derivative of this function. So you're given a function raised to a function. So the way we're going to approach this is by using logarithmic differentiation. So I do have a link in the description box below if you want to see how that procedure works, but let's dive into this problem. So the goal is to take logarithm on both sides. So we're going to take natural log on both sides. So let's go ahead and do that. Apply natural log on both sides. So once I do that, I have ln of y on the left side. On the right side, I have ln of x sine of to the power sine of x. Now using laws of logarithm, you can treat this as a exponent, of course it is, and you bring this in the forward. So if you bring this forward, you will have the following. You'll have sine of x times ln of x equals ln of y. And now you take the derivative respect to x. So once you simplify using laws of logarithm, you simply differentiate respect to your independent variable, that is x in this case. So on the left side, it's an implicit differentiation because we're differentiating ln of y. So ln of y is 1 over y times the derivative of y, that's dy dx. And on the right side, you're going to use product rule because this is a function, that's a function, so you have to use product rule. So you differentiate the first derivative of sine, that's cosine of x. You keep the second, plus, now you keep the first, which is sine of x. Now differentiate ln of x. Derivative of ln of x is 1 over x. And now we simply solve for this variable, which is dy dx, our derivative. Multiply both sides by y to get rid of the y from the left. So you have all of this times y. We have dy dx is equal to cosine of x ln of x plus sine x over x. Let's put parentheses so we don't misplace anything, times y. Well, what is y? Well, y happens to be x sine of x. I'm going to replace that here. So this is what you're going to replace right here for y. So let's go ahead and do that. So our final answer, our derivative, dy dx, is equal to cosine of x times ln of x plus sine of x over x times y, which is x to the power sine of x. So that is our derivative of the function. Let's try another example. Take a look at this one. We have y equals x to the power ln of x. We want to find the first derivative. So again, as we mentioned previously, we're going to apply natural log to both sides. So you have ln of y on the left, and on the right side you have ln of x to the power ln of x. And again, by using laws of logarithms, this can be bring forward. So you have ln of x times ln of x. All right, so that's a lot of ln of x. And on the left side, you have ln of y. So sometimes I put parentheses around the input, sometimes I don't. That's interchangeable. You can drop them if you want to. So now I can differentiate. I take the derivative on the left side and right side respect to x. So derivative of ln of y, that's 1 over y, times the derivative of y, that's dy dx. And now here again, product rule. So be very careful how you do that because you might get confused with ln x and ln x. So think of it as your first function is ln of x, the second function is the other ln of x. So I differentiate the first ln of x, I get 1 over x. Keep the second one, which is ln of x. Plus, now I keep the first ln of x, differentiate ln of x, that's 1 over x. And just clear things up. So the right hand side, you can write it as ln of x over x plus ln of x over x. And that looks like the same thing, right? So you have 2 ln of x over x, 2 of those. And on the left hand side, we still have 1 over y times dy dx. So I did a little simplification on the right hand side. Now on the left hand side, we need to solve for that. So multiply both sides by y to get rid of y. And then this will give us dy dx is equal to 2 ln of x over x times y. And what is y? Well, y is right here, x to the ln of x, and that's what we're going to plug in right here. So we know y is equal to x to the ln of x. So we substitute that for y. That gives us our derivative is equal to 2 ln of x over x times x to the power ln of x. So that is our final answer for this particular example.